Hello, welcome. The topic of this lesson is average rate of change and the derivative. So in this section, you will learn how to find average rate of change, the instantaneous rate of change, and the limit definition of derivative and their application in real life situation. So here are the objectives for today's lesson. So first we work on average rate of change and then we discuss about instantaneous rate of change as well as the definition of derivative. Okay, so before we discuss about average rate of change, I would like you to remind yourself the formula, slope formula from high school. Okay, suppose you are given 2 points in a line, let's say x1, y1 and x2, y2. How do you find the slope of a line? Well, it is y2 minus y1 over x2 minus x1. What does that mean? What that means is y2 minus y1 represent the, this is a change in y. So it's rise over run. So run is this x2 minus x1. This represents the change in x, which is delta x. So you can also write this as delta y over delta x. So the average rate of change is pretty much the same thing like slope of a line. So here is the formula. Average rate of change is change in y over change in x, or change in f over change in x. Okay, f of b minus f of a over b minus a. So we can find the average rate of change of a function y equals x over an interval ab by treating the function as though it were linear and using the slope between a and b. Even if the function is not linear, okay, let's say if our function is like this, and you want to find the average rate of change of this function between a and b within that interval a and b. So this point can be written as a and f of a, and this point will be b and f of b. Let's say this is my p and this is my q. So average rate of change is simply your y2 minus y1 over x2 minus x1, which means f of b minus f of a over b minus a. In another word, average rate of this function is actually the slope of a line PQ, and this line is called the secant line. We'll talk about that in detail later. I just want to remind you that we call this line as a secant line. So now we have the formula. Let us look at one example. Suppose we take a trip from Vancouver driving south to Seattle. Every half hour we note how far we have traveled with the following results for the first 3 hours. Okay, time is given in hours. So in 0 hour we travel, total distance travel is 0 mile. In half an hour, total distance travel is 30 mile. In 1 hour, total distance is 55, and so on. So here we need to find the average speed over the time interval from t equal to 0 to t equal to 3. So average speed will be, you see, time interval is this. Time t is 0 and another t is 3. So between that. In another word, this is your A starting, this is your A and this is your B. So basically average speed is given by f of 3 minus f of 0 over 3 minus 0. So f of 3 is, you see this one is your f of 3, which is 138 minus this is your f of 0, which is 0 divided by 3. And if you divide it, then you will get 46. 138 divided by 3 gives you 46 miles per hour. That is the average speed for that entire trip, 3-hour trip. Okay, now let's look at another example. So example 2, part A. Find the average rate of change for the function over the given interval f of x is 4x squared minus 6 between x equals 2 and x equals 6. Okay, again, average rate of change is, we know that the formula is f of 6 minus f of 2 over 6 minus 2. Let us calculate what is that f of 6 is. F of 6, okay, let me just copy the function here. F of x, which is 4x squared minus 6. So f of 6 will be 4 6 squared minus 6, and that's gonna give me 138, and f of 2 is going to be 4 2 squared minus 6, that is 10. So basically average rate of change is f of 6 is 138 minus 10 divided by 4, and that's gonna give me 128 divided by 4, that is 32. Okay, that is the average rate of change. Let us try one more problem. Our function is given to be 2x squared plus 3x plus 4, and we want to find the average rate of this function between x equals 2 and x equals 2 plus h. So average rate of change equals f of 2 plus h minus f of 2 over 2 plus h minus 2. Now let us calculate what are those values. I just want to copy the function first. F of x is 2x squared plus 3x plus 4. So f of 2 is, let me just calculate f of 2 first, which gives me 2 squared plus 3 times 2 plus 4, and that equals 18, and f of 2 plus h is 2 times 2 plus h squared plus 3 times 2 plus h plus 4. So if you simplify this, so you will be getting 2h squared plus 11h plus 18. Okay, you simplify it, you will get that. So our average rate of change is going to be, just substitute the value. So f of 2 plus h, we already calculated that this value to be 2h squared plus 11h plus 18 minus f of 2 is 18 divided by, as you can see, this 2 and 2 cancel out, you just left with h. And you can cancel this 18 and 18 also. So you will get 2h squared plus 11h over h. So you can take h common, so remaining 2h plus 11 over h, and this h is cancelled out, so your answer is going to be 2h plus 11. All right, that's how we can solve it. And here is one example 3. I just leave it to you. I think it's not a big deal. You can do it by yourself. Now, average rate of change as slope of secant line. Okay. So average rate of change, as I mentioned earlier, average rate of change can be interpreted as the slope of the secant line. So for example, we have a function, the blue line, as you can see, this is a function, and there is one point P and another Q. And if I draw that line PQ, then that line is called secant line because it touches the curve at 2 points. Okay, if the line touches the curve at 2 points here in this case, we call that secant line. And if it just tosses at 1 point and passes like this, just this another line here, the red one, it just tosses at 1 point, so we call that tangent line. Okay, now average rate of change is basically similar to the slope of the secant line, PQ. And suppose this is P is x and f of x, and let's say another point, I take another point at a distance of h. So this coordinate will be x plus h. Therefore, the point Q, the coordinate of the point Q will be x plus h and f of x plus h. All right. So using the slope formula or using the average rate of change, what we get here is that average rate of change from x to x plus h is f of x plus h, y2 minus y1. As you can see here, this is you can suppose that to be x1, y1, and this to be x2, y2. So now y2 minus y1, which means f of x plus h minus y1 is f of x over x plus h minus x. So this x and x can be cancelled out. So basically you are left with this formula, okay? F of x plus h minus f of x over h. So this is sometimes called different quotient. I believe you have done that in your high school or pre-calculus. This is called a different quotient. This is another name, or we can say that it is the slope of a line PQ. In other words, slope of a secant line PQ. Okay. Now, what is the difference between secant line and tangent line? You have just seen there. Now, as we have seen before, we need 2 points to determine the slope of a line in general. Okay, that's what we learn in high school, y2 minus y1 over x2 minus x1. So if we are given 2 points, then we can find the, slope. Now the question is, how can we find a slope? How can we find a slope of a curve at just 1 point? Okay, how can you find the slope of this curve, the blue curve, at 1 point at P? That is the fundamental questions for calculus, okay? So that means if we want to find the slope of this curve at a point P, then that means we need to find the slope of the tangent line passing through that point P. Okay, so slope of the curve at a point is actually slope of a tangent line passing through that point. So secant line, as we have seen, is a line between 2 points on the curve. A tangent line is a line that just tosses a curve at one point. Now, as we have seen earlier, so P and Q, if this point is X, then Q is here. This point is X plus H. And so PQ becomes a secant line. Now, imagine H becomes almost zero. If we take the limit of H almost zero, so the Q will almost coincides over P. Okay, Q overlap on P if H is almost zero. If I take the limit S tends to zero, then Q will almost overlap P. Okay, so Q will come over to P. If H is extremely small. So in that case, P and Q just becomes almost 1 point. And that means the slope of this tangent line becomes limit h tends to 0 f of x plus h minus f of x over h. So this is actually the slope of the tangent line, because when this h is almost 0, then P and Q almost overlap each other, and in that case you just get a tangent line passing through P, and given by this limit h tends to 0 f of x plus h minus f of x over h. So very important thing, when I take f of x plus h minus f of x over h, then this gives me the slope of secant line. Okay, it is slope of secant line, meaning slope of line PQ. But when h is almost 0, then Q becomes P, and I'll get this. So this represents the slope of the tangent line. Okay, so when you take the limit, it becomes slope of the tangent line. And that is actually, so if we let, that is actually the instantaneous rate of change as well. So if we let h approaches 0, then the point Q almost coincides P. So the slope of the tangent line at P is called the instantaneous rate of change. In other words, instantaneous rate of change means slope of the tangent line at that point. And it is often, slope of an instantaneous rate of change is often denoted by f prime of x or dy over dx. Just keep that in mind. Example, let us look at one example. So given the function f of x is x squared plus 1, find the average rate of change of f of x on the interval 1 to 3, the average rate of change of f of x on the interval 1 to 1 plus h, and find the instantaneous rate of change when x equals 1. All right, so let's look at solution. Part A. Average rate of change on the interval on the interval 1 and 3 is given by f of 3 minus f of 1 over 3 minus 1 So f of 3 is, as you can see, f of x is x squared plus 1. So f of 3 will be 3 squared plus 1. So that's going to give me 10. And f of 1 is 1 squared plus 1. That's going to give me 2. So this will be 10 minus 2 over 2, which is 4. Let's try part B. Average rate of change equals f of 1 plus h minus f of 1 over 1 plus h minus 1. So let us look at here. F of 1 is going to be, we already calculated f of 1, so let us calculate f of 1 plus h. So f of 1 plus h will be 1 plus h squared plus 1. If you simplify this, you're gonna get h squared plus 2h plus 2. Okay, so this value will be h squared plus 2h plus 2, and then minus f of 1 is 2 over, as you can see, this one cancel out. You're left with h, which gives me this 2 and 2 also cancel out. So you'll have h squared plus 2h over h common, remaining h plus 2 over h, and h is cancel out. So your value is, final answer here is 2h plus 2 or 2 plus h. Okay, now part C. So part C, instantaneous rate of change. So instantaneous rate of change is given by, just take the limit from this average rate of change, okay? Instantaneous rate of change, we need to find the slope of the tangent line at x equals 1. So how do you do that? So let me just, there are 3 steps, okay? So to find instantaneous rate of change, which means slope of tangent line, here is the formula we have just seen. It is limit h tends to 0 f of x plus h minus f of x over h. But because x is given 1, so you can replace that x by 1 plus h. So you can replace that x by 1 plus h and f of x, f of 1 over h. All right, instantaneous rate of change. So then f of 1 plus h, we have already calculated that. Limit h tends to 0. F of 1 plus h is, we calculated this to be h squared plus 2h plus 2 minus f of 1. We already calculated there, as you can see from here. So that is minus 2 over h. So this 2 to cancel out. So you're left with limit h tends to 0. This will be h common, remaining h plus 2 over h. This the after this, our goal is to actually evaluate the limit. So in order to evaluate the limits, as you can see, you can plug in the value directly, but if you plug in the value directly, you get 0 over 0. Okay, that's how we evaluate the limit. Recall from section 2.1. So in this case, you get 0 over 0, so we have to do some algebra. The easiest algebra would be h common, remaining h plus 2 over h, and this cancel out. Now you plug in the value of h. If you get a meaningful number, you're done. Otherwise, do some algebra again. So here, h is 0 plus 2, so that's going to give me 2. Okay, so that is the instantaneous rate of change at x equals 1. Now, let us look at this. If the cost function is given by f of x equals x squared minus 2x plus 12, find the instantaneous rate of change when x equals 4. So this can be done by two methods. First, let us look at method 1. I suggest that you follow the three-step method. First of all, we have, remember the formula is instantaneous rate of change is, you recall the formula first. Instantaneous rate of change is sometimes denoted by f prime of x, which is limit as tends to 0, f of x plus h minus f of x over h. So because we want to find at 4, in this case, f prime of 4 equals 4 plus h. This will be 4 over h. Okay. So we are given the function. We have the function f of x is x squared minus 2x plus 12. So you can write, you need to find 4 plus h. What is that? F of 4 plus h will be, we need to find f of 4 plus h and f of 4. So let us find f of 4 first. 4 squared minus 2 times 4 plus 12. That's going to give me 20. And let us find 4 plus h, which gives me 4 plus h squared. And if you simplify this, so you'll be getting 20 plus 6h plus h squared. So substituting this value in the formula, you're gonna get f prime of 4 is going to be limit s tends to 0. F of, as you can see, f of 4 plus h here which means 20 plus 6h plus h square minus f of 4, which is 20 over h. So if you simplify this 20 and 20 cancel out. Now you can plug in the value directly. If you plug in the value directly, you're going to get 0 over 0. So it means you have to do some algebra. So I think the easiest algebra here would be take h common, which gives me 6 plus h over h. This h is cancel out. Now plug in the value. Then you'll get 6 plus 0, which is 6. Okay, so the instantaneous rate of change for this function when x equals 4 is this. In another word, this is the slope of the tangent line to the curve f of x at x equals 4. Okay, this is our method 1. And there is another way to calculate this. Method 2. Okay, let us look at method 2. So we have the same formula. So, so the formula that we use here is that instantaneous rate of change. We use a very general formula, which is f prime of x equals. There we use, x at x equals 4 directly, but here in this case, we just use the general formula. H tends to 0, f of x plus h minus f of x over h. And then after we find the general, equations for the slope of the tangent line, then we plug in the value x equals 4 later. Okay. So in this case, again, what we need to find is, let me just copy the function here. So our function is, we have f of x equals, the function is x squared minus 2x plus 12. As you can see, we need to figure out the value of f of x plus h. Okay, so let us calculate. If f of x is this, then f of x plus h will be x plus h squared minus 2 times x plus h plus 12. So if you simplify this, you're going to get x squared plus 2xh plus h squared minus 2x minus 2h plus 12. Now substituting the value in the formula, values of f of x and f of x plus h in the formula, you're going to get f prime of x equals limit h tends to 0. F of x plus h means this x squared plus 2xh plus h squared minus 2x minus 2h plus 12 minus f of x. Minus f of x is minus, x squared, and then minus and minus will be plus 2x minus 12 over, because of the minus sign, we have to multiply this. We have to change, all this sign here. So, and the bottom part is h. Now, when we simplify the top part, so this x square plus and minus, positive and negative cancel out, 2x cancel out, 12 and 12 cancel out. Now, what is left here is that limit h tends to 0. Uh, if you plug in the value directly, what happens? You'll get this part 0, this part 0, this part 0 over 0. So that means it's undefined. So in this case, what you can do is, you know, the remaining term here. So the remaining term is this, this, and this. So in all of these, we can take h common. So let me take h common. So remaining 2x plus h minus 2 over h. So this cancel out. So I'm left with, you know, substituting the value of h now, you're going to get 2x minus 2. Okay, that is the, you know, general equations for the slope of the tangent line. Now we need to find the specific value when x is 4. So when x equals 4, our slope of tangent line f instantaneous rate of change, or slope of the tangent line at 4 is given by 2. Just substitute the value here. Okay, because we already got this f prime of x is 2x minus 2. Now when x is 4, f prime of 4 is going to be 2 times 4 minus 2, which gives me 6. Okay guys, this is all about average rate of change. So in this sections, what we have done is we begin with the basic concept of slope of a straight line that you learn in high school, and then we develop the formula for average rate of change, and then we learn instantaneous rate of change, and which can be interpreted as slope of the tangent line. And in our next class, in our next lesson, we will be working on definition of the derivative. Okay.